Hello and welcome to a tutorial about the technique known as looping in the Cobweb Designer. And the first question I think is, why do we need looping? Well, the documents that we work with generally have two types of data. There's the fixed data, which is often the header area and often a footer area as well. This data is always in the same place. You can see as we page through page 2, page 3, page 4, 5, 6, the data in the spool file, the header data, is all in exactly the same place. The addresses, the document number, the dates, they're all in the same place. That's the fixed data. Looping concerns itself with the variable data, which is often the item lines, and this constitutes this middle area. And as you can see as we go through the spool file, the item lines, they are in the same columns. The columns remain the same, but where they are on the page varies. Now, what is looping? Looping is the technique that we use in the designer to identify items that are varying in their position. And in this tutorial we will go through using the loop tool to identify the items using this example data and the various techniques that we use. So technique number one, keep it simple. We could not use a loop at all, and sometimes this is possible if we just use the select tool to select blocks of text like this. It may be possible to get away with just copying the blocks. And if that is the case, result. And the job's done. However, if we page through this spool file, we can see that on page 2 we've missed out this line here, which has come lower down. So we would need to increase the size of these blocks to pick that up. We're not picking up that item data, that additional data duplicated order. We haven't done anything with that continued line. As we page through, we can see that this item description here is going to cause us problems unless we copy the block exactly as it is on the input page. Here is the total for this page. It's going to be copied in through the block. So these are the common kinds of problems that we have, where copying blocks of data just isn't going to resolve the issue. So back to the drawing board, and we'll use loops. We'll go back up. We'll get rid of these items, these elements, and instead we will use a loop. Here's the loop tool, and to start off with, I will draw the loop over the entire area that I want to process. That adds an element into the Explorer tree here, which I will move down to below the header details. Keep things nice and tidy, and I'll put a description in there. Now if I page through the spool file again, I can see that I'm not quite picking up all of the items. So I'll adjust my loop. again. Okay, so looking at the data that we have got, our loop now covers that area. Now I look on the output pane and I can see this is, if I move the loop, the output loop, that neatly fits into the overlay that's been designed. If you find that the output loop doesn't fit into the overlay that's been designed, it's quite often an indicator that the overlay has been designed with an item area too small to fit all the information. But in this case we're fine. Okay, so now what we want to do is to start identifying our item lines. Now, if I look at this data here, what I'm looking for is a way to specify, to differentiate an item line from, say, the total data, or this goods return shipping data here, this additional text here, the item description, the continued text. What I can say with all of this information is that an item line can be defined if there is some text here. If I go through the other pages, the only time that there is data in this column is when there's an item line. So that is a good test. So I take that and I'll put that in the loop. And I can add another test just to be sure. I mean, if I look here, there is always data here in the date column, in the units of measure, in the item description. So as you can get as detailed as you want with identifying the items. This item line test, the first one, we want to check when it's not blank, when this area is not blank. And the same with the date column. So when those two areas are not blank, we know that we're on an item line. So that's our item test. And what do we do once we found an item? We want to copy the data across. So that would be taking this data and all these items have been, elements have been added inside our item test. Fill out the element descriptions. Now, we come to what I think is possibly the most complicated aspect of looping, and that is the theory of relativity. Now we have identified an item line here. The theory of relativity states that all of a branch in a loop, the position of every item in that is relative to the root element of the branch, which we call the anchor. What this means is that this first test here acts as the anchor. And the way that looping works is that this test will be run on each line that has been specified in the loop. So this loop has been specified to start on line 23 and run for 24 lines. So this test here, although it's currently on line 24, the first time that this loop goes round, this test will be run on line 23. And that will find that that area is blank. So that test, is this area not equal to blank, will fail. So none of these sub-elements will be processed. Then the loop will come back round and will do exactly the same on line 24. That test will be run on line 24 where it's not equal to blank. So that branch will carry on, and the next test will be evaluated. And the crucial thing is that this test will be evaluated relative to where the root item, the anchor element, was tested. So that will be tested on line 24, and we will find the test is passed. The area is not equal to blank. So all the sub-elements will be processed, and all these sub-elements will be copied relative to the anchor item. So that area will be copied, these areas will be copied, and where they will be copied to is to the second line down in the output pane. So relative to the second line down in the output pane. And this is crucial because it helps you to position where you want all your output to be. And the general rule of thumb is to position all your root elements at the top of the loop on the source, and then all of your sub-elements relative to that root anchor element, and then all of your destinations relative to the top line of the output loop. Now once this test has been completed on line 24, then obviously it will carry on and being tested on line 25, 26, 27, 28. And the crucial thing to note is that each time the source line is incremented, the destination line is incremented. So the loop processes all of the input lines and copies the data line by line to the output. Okay. That is essentially the key parts of looping. There are some advanced functionality that is required to go beyond just this basic example here, and I think a few more examples will illustrate that functionality. For example, if we look page down back to this page 3, we'll remember that there's some item description. Now this item line test, when it comes down to this line, which is line 26 on page 3, this test will fail, so none of this data will be copied across. So we need another test, another anchor to test for this item, for the special item description that follows on. And a useful test could be, in this case, to say if this area is not blank. Sorry, if this area is blank. So we know that we're not on an item line, but we have got some item text. So our item description could be that this column is blank, but this area is not blank. And when those two conditions are met, we want to copy this bit of text across into the description field. Now again, as we said, once you've defined your branch, it's generally considered good practice to move all of those items up to the top of the loop to maintain that relativity. So now we've done the item description test. There's one other piece of information I saw further back here, this carriage charge test. The item description says if this area is blank and this area is not blank, well, this would then be considered item description, but only this piece of text is going to be copied across. So we need to adjust our item description test to not include the goods returned text, delivery text. So we could add another text test in there to say if this area is blank. Because on an item description, this area is blank, while this area is not. That leaves us free to identify our delivery instructions by again testing whether there's an item, checking this is first column is blank, and then checking this second area is not blank. And that will pick up both lines. Firstly, it will pick up on line 42 of the loop, it will pick up the goods return, and on line 43 it will pick up the charge text. So let's again move this. This is again, we'll move them up to the top. There. Okay, so there's a couple more examples of using standard relative item line tests. I want to introduce an advanced concept of absolute positioning, because sometimes you want to specify exactly where the output is going to go on the output pane rather than allowing it to be relative. For example, this total text. It appears on line 46 on page 1, and then right up here on line 27 on page 4, and then it's further back down on page 6. It's entirely possible to identify it. This time we're going to use if this area is equal to total, because that text is always going to be constant. Then we're going to copy the total value and on the output pane we're going to put it down the bottom. But the key factor here is we check the force absolute checkbox. That means no matter where we find it, whichever line we find it on the input, we will always output it in an absolute position on line 57 of the output pane. And again, we can do the same with that total text. Force absolute, they will both be output on line 57 of the output. Now you'll notice that there is a force absolute on both tabs. The key to remember is the general tab. All the information on the general tab is about the output, whereas the information on the spool file tab is all about the spool file. So if you select force absolute on the input pane, imagine we wanted to test when we find a total that the owner is Matthew. Now that total being a anchor in the loop will be relative. So that test will be tested, it may be on line 23 that it finds total, it may find the total on line 27, this next test is relative to that test. So it is testing on a line 27 minus 12, 15 lines further up. On line 27, sure, it will find Matthew on line 12, but on line 23, 15 lines further up, is line 8. So it will be testing for Matthew on line 8, and it won't find anything. So in that instance, what we're talking about is we're talking about an absolute test. So this test will be tested on line 23, 24, 25, 26, 27. But this position test will be tested always on line 12. It will equal Matthew, therefore the totals will be copied. And this total will be copied relative to the anchor test on line 27, but it will be output absolute on line 57. I'll just change these descriptions where I'll let you sink in. Okay, so that's absolute positioning. There is one more advanced technique, and that's the parameters of the property. So far we've worked with a vanilla loop, but there are some options in a loop. The first and most useful is the loop to end of page. Now what you find, as we've seen, is that your design can only be as good as the data that you're provided with. And in this instance, we've been provided with 3 different samples. But what we can often find is that there are other samples where the line data goes on further than we've been given examples of. The loop to end of page option will mean that the loop will carry on to the bottom of the page even if it's longer than the longest page that you've been given as an example. So switching that on can be a very useful feature. The loop to end of document is almost never useful. What that will do is when it gets to the end of the page, it will continue looping on the next page of the spool file and the next page until it gets to the end of the current document. It may seem like a good idea sometimes, but the problem with that is that you will often end up with an awful lot of output, more than you can fit in your output pane, in your output page. And there's no real way of controlling that. So except in very rare circumstances, loop to end of document is not usually the answer to your question. Finally, increment destination counter on success only. Possibly our favorite checkbox in PPD Designer, but mainly because of the name, not because of the functionality. Again, this seems like a useful tool in that what checking this box does is, rather than locking the input and output lines so that every time the loop finishes and the next line is processed, then the output pointer is incremented as well. Checking increment destination counter on success only means that the destination line is not incremented by default, but is only incremented if one of these tests results in being true. What does that mean? Well, if we look at line 1 of this loop, the item line test fails because this area is blank. The item description test fails because this area is blank. The delivery instructions test fails because this area is blank, and the totals test fails because this area does not say totals. So none of these tests have been true. The item loop will then increment on the source side and start processing line 24. However, because none of them were successful, the source output line will remain on line 34. This has the effect of squashing the input into a much smaller space and getting rid of often blank lines. This design as it stands at the moment would take the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 24 lines of input on this page and not be successful on 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So it would squash this 24 lines of input into 12 lines of output on the output pane. And that can often seem like a really good idea, and indeed it is, but you have to be very careful about which lines end up being considered successful and which lines are not. And that's something you have to bear in mind. And the final advanced functionality is break loop. And this is less used when you're processing items and more used when you're using loops in a more traditional programming sense. Sometimes loops are used to search for a data rather than to process items. For example, it may be that the spool file has it outputs addresses that are a variable number of lines, and you want to know how many lines, or you want to load up variables with the last line from an address. You could do that using a loop over the total address area, and then testing loading up a variable, say with the data if it's not blank, and then on the first have another test on the first blank line that you come across, break the loop. Well, as soon as break loop, a condition is true that has the break loop checked, the loop stops processing and moves on to the next element in the Explorer tree. So in this instance, that variable would not get loaded up with the value of the blank line. The loop would be broken and you could carry on with your processing. Again, advanced functionality. Well, I think that concludes this tutorial. Thank you for watching. If you have any questions, do get in touch with us at support@cobwebcommunications.com. Thank you very much.